Okay, so all we're going over today is how to determine whether something is a function or not. We're going to look at things like ordered pairs, tables, maps, and graphs. So, a function is a relation that pairs each input with exactly one output. That basically tells us that since inputs are x and outputs are y, that tells us that we cannot have a repeating x. That's pretty much all that tells us. So we look at part A. We have -2, 2, -1, 2, 0, 2, 1, 0, or 2, 0. Those are all ordered pairs, right? We have to determine whether this set of pairs is a function or not. So all we have to do is look at our x's. We have -2, -1, 0, 1, and 2. Are any of those x's the exact same number? No. Since they're not, this is a function. So we put yes. And the way to explain that would be there's no repeating x's. You can also put, which I would like better, no repeating inputs. But I know remembering x is easier. Okay, we look at part B. We change color so it's easier to see. We look at part B. We see 4, 8, 6, 4, and 5. These are all x's, correct? I see we have 4 and 4. Those are the same exact numbers. Since we have two x's that are the exact same, this is not a function, so no. And we'll say 4 is repeating. So, pretty much all this is if there's a repeating x, it's not a function. If there is not a repeating x, it is a function. And just remember, when we look at an ordered pair, it's just like the alphabet. X comes before y, so x is our first number, y is our second number, right? Okay, we're going to move on. So, you're going to get things that look like a table, or things that look like a map. In the table, again, to tell if it's a function or not, we look at our x's. We have -2, -1, 0, 0, 1, and 2. Looks like we have 0 repeating, which tells us this is not a function. So no. 0 is repeating. Okay? And now we look at the map. This is a little tricky to look at when you look at something like this. This tells us that -1 pairs to 4, 3 pairs to 15, and 11 pairs to 15. It may be easier to write the ordered pairs that it represents. So, as I said before, x is our input, right? So that's the first number. So we have -1. It pairs to 4. We also have 3, which pairs to 15, so 3 and 15. We also have 11 that pairs to 15. So these are the 3 ordered pairs that came from this map. Do we have a repeating x? No, we do not. So that means it is a function. So yes. So as I said before, it's pretty easy to tell whether something is a function or not based on a table, a map, or ordered pairs. All we're looking for is a repeating x. If we have a repeating x, it is not a function. If we do not have a repeating x, it is a function. You can think about it this way. A function is an equation. When you solve an equation, so let's say we're solving for x, you're coming up with one answer, right? We don't come up with the same answer twice. Okay. Go ahead and try monitoring progress. Pause the video. 5, try it on your own. We're about to go over it. Okay, we look at number 1. We have to tell whether this is a function or not based on the ordered pairs. We look at all of our x values, and I see 5 and 5 repeating, so no, this is not a function. 5 is repeating. Remember, we're not necessarily looking at the y's. All we're doing is looking at the x values. That is it. We look at number 2. I see -4, -1, 2, and 5. None of them are the same, so yes, this is a function. Okay, we look at the table over here. I see 2, 4, and 6 for x's. None of them are the same, so yes, this table is a function. And we look at the map. Again, we talked about this. You can write ordered pairs. We know 1/2, which is an x, is paired with -2, 0, and 4. So that means we would have 1/2 and -2, 1/2 and 0, and 1/2 and 4. -1/2 is repeating. So no, this is not a function. 1/2 is repeating. Again, if an x value is repeating, or there's the same number more than once, it is not a function. If there's no repeating x's and they're all different, it is a function. Okay, vertical line test. We use the vertical line test in order to tell if a graph is a function. So here's 2 examples. Here's one coordinate plane. I'm going to give you another coordinate plane. And we're going to do some examples. One example is going to be why it doesn't pass the test, and one's going to be why it does pass the test. So let's do 3. So let's say we have 1, 2, 3, -1, -2, -3. Again, we don't really care about the y's because we're still trying to figure out if this is a function or not. So let's say we have a point here, we have a point here, we have a point here, 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 and let's say here. It's a lot to look at, right? There's a lot of points on this graph. All we have to do is we identify, and we just have to look if the same x is used more than once. And if we look here, if we draw our vertical line, it looks like the 2 value is used twice in the x's place. So it does not pass the test. It is not a function. Now, you don't have to use the vertical line test every single time if you don't want to, but I recommend it if you can't identify the x's right away. The vertical line test is perfect to use. Now, over on the right side here, I'll draw a line. So you might get a graph that looks like this. Okay, in this situation, we draw our vertical line pretty much anywhere. Let's draw it over here. We know that the same x value is not going to be used more than once, so it does pass our vertical line test, so it is a function. So yes, it is a function. So that's what the vertical line test is used for. We're going to try it out on a couple of these graphs down below. Okay, so we have a graph here and here. It's 2 different graphs. So we look at the first graph. We need to check to see if it passes the vertical line test. So let's look. I see a repeating edge in 2 locations. First, if I draw my vertical line here across 2, I see that there's 2 of them being used. Again, if I draw a vertical line here, going all the way through 5 on the x-axis, I also see 2 of them being used. So, In this situation, it is not a function because it does not pass the vertical line test. Now, you can either say it does not pass the vertical line test, or you can say 2 is used more than once and 5 is used more than once. It's as simple as that. We go over here. This is a line typically represented by slope y equals mx plus b. If I draw a vertical line anywhere, it's never going to cross the same x more than once. So this is a function. It passes the vertical line test. Remember, the vertical line test we just use on a graph to see if there's an x used more than once. That's all we are doing. And again, you do not have to use the test. If you just look at this and say, oh, I see 2 dots right on top of each other, that means they're using the same x, I know it's not a function. You can totally do that if you want. I recommend the vertical line test, but this is completely up to you, right? Okay, we're going to do one more set of practice, and then we're going to be done. Okay, go ahead and try these two, and we'll go over them. Go ahead and pause the video. Okay, we look at this first one. We see, if I draw a vertical line, here, 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 and here. If we draw a vertical line on every single point, it's not going to be the same x-axis. So this is a function. It passes our test, right? Okay, and if we look at the one on the right, it looks kind of confusing, but if we do a vertical line test at many different places, we're going to see that x isn't used more than once. Just because we have 2 here, and it's moving up here, that's like 2.2, right? It's not being used more than once, so this is a function. So yes, it passes our vertical line test. It is a function. Remember, a function is when x is not used more than once, or the input is not used more than once. Okay, we're going to move on to the next 2. Go ahead and identify whether these 2 are functions or not. Go ahead and pause the video, identify them, and we'll go over it. Okay, we look here, we look at the circle. We draw a vertical line test, or if we draw our vertical line, it looks like it crosses here and here at 3. And if we did that again, on all the different sections, it would pass more than once on multiple of them, right? So it does not pass a vertical line test, therefore it is not a function. So a circle on a graph is not a function. Now we look over here. We kind of went over this when we were talking about the vertical line test. We know in this situation, if we were to draw a vertical line, I know it's not a very straight line, but it's a vertical line. We see that in no location is the same x going to be used, therefore it is a function. Okay. Last thing we're going to talk about, and we will talk about this more tomorrow, is the domain and range. I'm going to give you guys a definition today, and like I said, we will talk about this tomorrow. We will talk about what the domain and range are. So the domain, typically it's x. The range typically is y, but sometimes other letters will be used. The domain is all possible input values. Okay, therefore the range is all possible output values. So the domain is all the x's, the range is all the y's, or like I said, sometimes it'll be a and b, sometimes it'll be z and x. You know, it just really depends on what letters they want to use. But it all depends on our function or our equation. See how we have a y and an x here? So the input or the domain goes into the function machine. So -2 is going into the function machine. It's being plugged in for x in this situation. Y equals 3x, so that's y equals 3 times a negative 2. 3 times a negative 2 is 6, and that's where we get our output. That's how functions work. You put the input in, which is what you're plugging into the function, and the output is what you get at the end. Again, we will talk more about input, output, domain, and range tomorrow, so make sure you get these notes down, ask me any questions in class, and do your assignment on big ideas.